In this problem, we are going to look at a question which looks very difficult, but is actually not so tough at all. So let's get into it. We have let f of x and g of x be differentiable functions of x such that x square times g of f of x multiplied by f dash of g of x multiplied by g dash of x is equal to 1 minus 2x square times g dash of f of x multiplied by f dash x and multiplied by f of g of x. And this result is true for all x belongs to real. This result is true. It is also given that gx is positive and fx is non-negative, right? So basically that means that gx is greater than 0 and fx is greater than or equal to 0. And it is also given that 0 to k f of g of x dx is equal to 1 minus e power minus k square. We have to find the value of GIF of ln g of f of 3 divided by g of f of 2. So this problem looks very difficult. It's a long problem to try to understand, but once you get the hang of it or once you approach it without fear, you can easily solve this problem. It is not a very difficult question actually. You have to look at this differential equation carefully, or this functional equation, whatever you want to call it. So notice one thing, there is g of f of x, there is f of g of x, right? And there are also terms like f dash g of x and g dash x. Think about this. These two terms would be what you would do if you want to differentiate this, right? Differentiation of f of g of x is f dash g of x times g dash x. And similarly, these two terms are what you would do if you want to differentiate g of f of x. That would be g dash f of x into f dash x, right? So technically the derivatives of this composite function are on the other side and this composite function is on the other side, right? So that gives us a hint that maybe we can think about it in that sense. Now, what we will do here is we will divide by f of g of x. We'll write it like this: x square f dash g of x times g dash x divided by f of g of x is equal to 1 minus 2x square, and this side is g dash f of x. Okay, I'll actually do it on the next screen. So you should write down the question, try it yourself for a bit and see if you're making any progress. I will solve it on the next screen. So what I'm doing is x square here, and I am putting f dash g of x, keeping that on the left hand side itself, keeping g dash x also on the left side, and I am bringing f of g of x from the other side here. And similarly, on this side, I'm going to put 1 minus 2x square, which was already there. G dash f of x was already there. F dash x was already there. I'm bringing g of f of x from the left-hand side, right, to this side. So now think about it. This whole thing, you have the function in the denominator and the derivative in the numerator of that function, right? So if you have done a little bit of calculus, you know that this is the differentiation of log of f of g of x. You should be able to spot this. What is the derivative of ln f of g of x? It would be 1 by f of g of x, and by chain rule, after that you will do f dash g of x times g dash x in the numerator, right? So this is looking like this. X square into this is equal to 1 minus 2x square into derivative. This is also derivative of ln of g of f of x, right? Because again, g of f of x is in the denominator, and on top you have g dash f of x and f dash x. So this is my first result. I have simplified my expression and made it look much better, right? Secondly, I also have integral of 0 to k f of g of x was given in the problem, and this was equal to 1 minus e power minus k square, right? Think about it. This is a function of x, but when you integrate it, the expression will also come in terms of x. However, the limit is in terms of k. So the overall thing on the left hand side is a function of k, right? After doing the integral and putting the limits, it will become a function of k. And this side also, it is a function of k. So what I should do here is, in order to understand what is f of g of x, I need to remove the integral sign. The way to do it is to differentiate the integral, but I will differentiate with respect to which variable? I will differentiate with respect to k. I have to do a d by dk for this because these are all functions of k. So if you do that, you will get f of g of k by Newton-Liebniz rule multiplied by 1 minus 0 is equal to the derivative of this side will be the derivative of minus k square is minus 2k. So it becomes a 2k into e power minus k square, right? So that immediately solves almost the entire problem for us because it just tells us what is f of g of x. F of g of x is 2x e power minus x square, right? One simple differentiation of this gives us the f of g of x, right? And since we know f of g of x now, what is ln of f of g of x? Ln of f of g of x will be ln 2x plus ln of e power minus x square. So that will be ln 2x minus x square, right? Okay. So now that we know this, we can easily find the derivative of this. So derivative of ln of f of g of x would be 1 by 2x times 2 minus 2x. So it is 1 by x minus 2x. That is the derivative that is coming for ln of f of g of x, right? So I will put that in this equation now, and I will write the result on the next page. So I have x squared times 1 by x minus 2x is equal to 1 minus 2x squared, and the derivative of ln of g of f of x. We don't know that composite function. We have figured out what is f of g of x from the given condition. So we get basically x minus 2x cubed divided by 1 minus 2x square is equal to derivative of ln of g of f of x, right? And this clearly you can take x common, 1 minus 2x square cancels. You have x is equal to d by dx of ln of g of f of x, right? And therefore, by integrating both sides with respect to x, I get x squared by 2 plus c is equal to ln of g of f of x, right? Now, what we need is the ratio of ln of g of f of 2 or 3 divided by g of f of 2, right? This ratio is being asked in the problem and with a GIF outside. So if I want to find ln g of f of 3, I will do ln g of f of 3 is simply 3 square by 2, so 9 by 2 plus c, and ln g of f of 2 will be 4 by 2 plus c. So the difference of these two will give me this, and that is clearly 5 by 2, right? And the GIF of 5 by 2 is easy, and that is 2. So the answer for this problem is 2. And actually, it is not at all difficult. All you have to do is recognize that the big long expression in the beginning was actually derivatives of two log functions, log of FOG and log of GOF. those two log functions were being differentiated and you had x square and 1 minus 2x square on the two sides. And then you have to use Newton-Liebniz formula to differentiate the integral with respect to k, and you can find f of g of x. And after that, it is a straightforward, put it back in the original relation and solve the equation. So what you should learn from this question is, don't get overawed by the way the question is presented. The question might look scary. You have to approach it without fear. You have to approach it as if you know how to do it. You need to try different things with an open attitude. And if you have that problem solving attitude, then you will be able to solve the problem. It's more about confidence in problems like this. You have solved many questions in your JEE advanced practice, which are enough for you to crack these problems. It's just about approaching the problems with an open mind and not getting scared and not giving up after a little bit of an attempt. If the first idea doesn't work out, you need to keep trying, right? So these problems that we are discussing in this series are aimed at helping you learn this art, the art of problem solving. Keep solving, keep trying, and I'll see you next time.